Alright, in this video we are going to look at how voltages work in a three-phase delta system. In a delta system, our generator has the three windings connected as a delta connection. So the three windings do not have a common point like they do in Y. They are connected end to end to each other in that generator. And the three-phase windings, one is A to B winding, one is B to C winding, one is C to A winding. If that delta generator feeds a delta connected load, the load will be connected the same way as well. Each load will not have a common point like it does in Y, but will be connected, one end of load connected to line A, the other end to line B, one load connected from line B to line C, one load connected from line C to line A. And to look at voltages at this system, we can look at each phase or line at a time. If I look at the generator and I have a winding connected from A to B, that is the phase. At the generator, that is my phase. My winding is connected across it. But the voltage that it produces, the voltage that phase A to B produces, because it's connected across line A and B, is the line voltage. So the 480 volts we have at the phase winding, A to B, is the line voltage, A to B, and is also the voltage that the load in phase A to B sees as well. So the line and phase voltage are the same thing for phase A to B at my load. For phase B to C, the voltage produced by the winding in phase B to C is 480 volts at my generator. That is connected across line B to C. So the phase voltage at the generator equals the line voltage leaving the generator for B to C. It also equals the voltage connected across the resistor in phase B to C at the load. So again, line voltage and phase voltage are the same. The same goes for phase C to A. The third winding in my generator that is connected across phase C to A produces 480 volts, and that phase voltage connected between C and A is my line voltage leaving the generator and is what's connected across the last resistor at my delta load connected on phase C to A. So the line voltage equals the phase voltage again. The rule for delta, the first rule for delta is that phase voltage equals line voltage. There are not two separate voltages for delta. There is only one. The phase and the line voltage are the same thing. Again, this drawing here is just showing that at my generator, the voltage across A to B is the same as the line voltage leaving. The voltage across phase B to C is the same as the line voltage leaving. The voltage across C to A is the same as the line voltage leaving that generator to feed a load. And these three voltages, if they were shown as sine waves, would be three sine waves that are 120 degrees apart because the windings, in the generator are 120 degrees apart. So these three voltages, VA to B, produce a sine wave. VB to C would be a sine wave 120 degrees later. Voltage C to A would be a sine wave at 120 degrees after B to C. How do we plot these voltages on a phasor diagram? In your ILM three-phase delta connection, if you look on page 6, you will see the standard way that we show voltages for a delta system. And what we do is we always show the first voltage, phase A to B, is drawn right at 0 degrees. So phase A to B is drawn at 0 degrees. Phase B to C is drawn 120 degrees later. So the phase or line voltage B to C is drawn at 240 degrees. And phase voltage C to A is drawn 120 degrees behind phase voltage B to C, and voltage C to A is seen at 120 degrees. So for our phasor diagram for voltages for our delta system, we have only three voltages. VA to B at 0 degrees, VB to C at 240 degrees, VC to A at 120 degrees. will reemphasize that the rule for delta is that line voltage equals phase voltage.